This final example is another really common situation where you're starting with a clear cut and you're going to establish a new stand. And our question is, what should the rotation length be for this stand we're going to plant? In this case, our objective is to maximize revenue, so a relatively straightforward objective. Okay, so starting with the clear cut, what rotation age? So because we're wanting to maximize revenue, I'm going to look at some intensive loblolly pine scenarios. So the only difference in these three scenarios will be the rotation age. When does the final clear cut happen? So we're going to compare clear cutting at age 20, 25, and 30. Up to that clear cut, the scenarios will all be the same. So we're going to start with a stand with a side index. You will determine this for your particular track, but let's say the side index base age 25 is 70 feet for loblolly here. We're going to site prep by bedding and broadcasting herbicide. We're going to machine plant full sib loblolly pine at 500 trees per acre. We're going to do herbaceous weed control 1 year after planting. Then we're going to fertilize at age 5 with 135 pounds per acre of N, 15 pounds per acre of P. Thin 70% of trees at age 15. And I ran the growth and yield model to determine that I needed to thin 70% to arrive at a residual basal area of 60, which is sort of a typical target residual basal area. You'd want to shoot for 60 to 70 square feet per acre residual after most thinnings. And then it's a pretty common prescription to then fertilize at thinning or immediately after thinning to give those residual trees plenty of nutrition. So we're going to fertilize after thinning 225 pounds per acre, nitrogen 25 pounds per acre of phosphorus. Okay, and then test different rotation lengths. Reminder, because we're testing different rotation lengths, we can't use net present value to compare these scenarios. We have to use land expectation values. Okay, so here are those LEV scenarios or LEV analyses for those different scenarios. Okay, just an example of what the growth and yield modeling looks like. In this case, for a rotation age of 20. Okay, so I ran the growth and yield model with all of those inputs that I listed on the previous slide. With a thinning at age 15, remove 70% of the trees, and with a residual basal area of 60 square feet per acre, and that thinning producing this amount of chip and saw and pulpwood. Okay, and then a clear cut harvest at age 20 that produces products as specified here. Okay, so this is what your growth and yield output will look like for that 20-year scenario. Just to reiterate, for all three scenarios, age 20, 25, and 30 rotation ages, this thinning output will be the same because the scenario is the same, through that thinning. The only difference will be the final harvest and the associated yield associated with those final harvests. So here's the LEV analysis. Intensive lob, 20-year rotation. I've got a discount rate of 5%. In this case, I'm doing all these calculations on a per acre basis. So I would need to scale this up by however many acres my tract is. Rotation length of 20, and this is a cell where I've entered 20 because I need to reference that rotation age for these calculations down here. Okay, so age 0, I do my site prep. It's already been clear cut in some previous operations, so those revenues aren't here, but I bed it, apply herbicide, and plant those loblolly pine seedlings. And these are the costs associated with that, and the time adjusted cost. It's year zero, so the time adjusted cost is the same as the actual costs. The year after planting, I go ahead and do that herbaceous weed control, $140 per acre. Here's my time adjusted cost. And then I fertilize at age 5 and 15. Those are the costs associated with that. And then these are the revenue. This is the yield associated with that age 15 thinning and the revenues associated with that. And then this is the time adjusted revenue of that thinning. And then this is the age 20 year clear cut harvest. These are the yields from the growth and yield model. And these are the revenues associated with those yields and the time adjusted revenue. Okay. This is the sum of those time adjusted revenues, sum of time adjusted costs. That minus that is $562 per acre net present value. But remember, we're not using net present value here. We need to do land expectation value. So basically I need to take this net present value of that scenario, calculate its future value for a 20-year rotation, and this is its future value. And then calculate the present value of a perpetual repeating series using that future value, and I get a land expectation value of $901 per acre. So that's my land expectation value for my 20-year rotation scenario. Okay? So we do the same thing for a 25-year rotation. Okay, so up through this point, same scenarios, same site prep, same herbaceous weed control, same fertilization treatments, and same thinning. So everything up through here is the same. But in this case, we grow the stand out to age 25. These are the yields associated with the final clear cut at age 25 and the revenues associated with that. Net present value of 678, future value of that net present value, and the land expectation value of $962 per acre associated with that 25-year rotation. And then here's the calculations for a 30-year rotation length. Again, site prep, herbaceous weed control, fertilization, and thinnings, those are all the same as the other scenarios. The only difference is the timing of that final clear-cut harvest and the yields associated with that from the growth and yield model. Net present value of $623 per acre and a land expectation value of $810 per acre. Okay? So, looking at the outcomes from those, 20-year rotation, 25-year rotation, 30-year rotation, we can see they have different net present values, but we don't look at those because they're different lengths, and so it's not valid to compare their net present value. It is, however, valid to compare their land expectation value. So what we can see is that we have the highest land expectation value with the 25-year rotation. So because we're maximizing revenue, I would choose the 25-year rotation as the most efficient option because our land expectation value is highest for that option. So some take-home messages. So when we talked about models, we said models are not gospel. They're not written in stone. They are tools to help us make decisions. And cash flow analysis and scenario analysis are the same. They're not gospel. They're just tools we use to help us make decisions. So net present value or land expectation value are important, but they're only one consideration that we use. So especially if those cash flow outcomes are similar, other criteria should come into play. What are the other objectives that the landowner has, and does one particular scenario help meet those secondary objectives better? Are there some operations or scenarios that meet the cash availability needs of the landowner better? Or is there one scenario or another where aesthetics are better? So we should consider other things in addition to cash flow analysis, especially when the outcomes from the cash flow analysis are similar. That being said, always keep in mind that these types of analyses, they're on the computer, so they're fast and cheap. Don't forego looking at a potentially promising scenario because you don't want to run the numbers. It's cheap and fast to run the numbers. Once you have your growth and yield model open, and once you have your spreadsheet for your cash flow analysis set up, it's pretty easy to look at multiple scenarios. So don't skimp on looking at different scenarios. It will only help you find a solution that is advantageous to your land.